Hey, excellent. Right, okay, I'm going to try and distill the past 3 years of my life into something interesting and in 5 minutes. So let's go with this. A photon is basically just light. Okay? Particle, wave, doesn't really know what it is. But I'm going to make it interesting. So it's an intergalactic wacky races. On your marks, we've got two neutron stars. They're spiraling around each other, releasing gravitational waves. They're losing energy by releasing gravitational waves, so they're falling into each other, and they're going to collide, and bang! The race hasn't started yet. We're getting ready. They collide, and they're going to produce two massive jets coming with the magnetic fields of relativistic material coming out of these. Bang! Like that, okay? Here we have like a klaxon of the race starting. Internally, gamma rays being produced. Gamma rays coming out first, and then after that, we've got radio waves, light waves, X-rays, and we're just going to look at the contestants of the light waves. We've got ultraviolet with a wavelength range of 380 to 450 nanometers. Energy, 2.75 to 3.26 electron volts. Oh, sorry, news just in. The shocked element has hit the interstellar medium, and we've got a reverse shock propagating back down the jet, into the jet, releasing even more photons. So, yeah, we've got the visible light that's being produced, and we've also got some outsiders. We've got the X-rays, strange beasts. They like to be referred to themselves as electron volts. They're good at imaging DNA, curing cancer, and radio waves as well. They're going to try and break out of the galaxy and break into the galaxy cluster. There's lots of dust there. And it's really difficult to break out if you are high energy, short wavelength photons. So it really sucks to be blue. Basically, the reason why the sky is blue is because photons of the blue wavelength don't travel in a straight line. They get knocked into different perspectives, and why we see the sunset as red. Now, this is a point-to-point classic race because photons only travel in a straight line. And they might travel around galaxy clusters, but equally, they think they're traveling in a straight line. The gravity bends them. But it takes 8.5 billion years. And how much longer have I got? Oh, sorry, no, it's okay. We're doing it from the perspective of a photon. Now, the twin paradox is that if you send a twin to another planet and comes back, they will experience less time. Now, photons, they travel at the speed of light, which means that their clocks essentially stop, and distances essentially become infinitesimal. So the photons don't believe that they're traveling that far. Now, whilst they have the ravages of time, they're not affected by that. They get very fattened by it. Universe is expanding, stretches out the photons as they're traveling, and the blue becomes green, so it doesn't suck to be blue anymore. And it stretches out the photons. They come into the Milky Way, and luckily they're coming in edge on, or face on, rather than edge on, so they're not absorbed by this chance. And what have we got next? Remember, we have the gamma rays. The gamma rays hit the Swift satellite, which detects them. It spins round using classified military technology to face the gamma ray burst, sends a transmission to Earth. The gamma rays can't get through the atmosphere, the X-rays can't get through the atmosphere, the visible does, and wait, yes, we've got La Palma online. It's nighttime in La Palma, and we've got the Observatorio de Roque de los Muchachos Observatory, and that's one of the easternmost Canary Islands, 2,400 meters. Great for fans, and the Liverpool Telescope is there, run by John Moores University, with a clamshell dome. It stops what it's doing, sends a text message to the whole team, and it slews to the position of the gamma ray burst. And the photons are hitting everywhere, but it's not there yet. Oh, and then it bounces off the first mirror, bounces off the second mirror. Good news is, it's aluminum coated, fans. Aluminum coated. Good news for the blue photons. But there's a bit of dust on the mirror, so only half of them are actually getting through. Right, down to the instrument. After 3 reflections through the mirror, into Ringo 3. The colours are split by 2 dichroic mirrors, into red, into blue, into green. They create photoelectrons, charge, which lands in the CCD. Bad news for blue again, we're not as sensitive in the blue. And this is it. This is the end of it. 12:03:08 happened on the 12th of, no, 8th of March 2012, a gamma ray burst with light that had travelled for us about 8 billion years, for the photon, a couple of seconds. Thank you very much.